All right, this is the last section of the material that I'm going to test you on for the first test. So this is it. After this, that means I'll review a little bit Wednesdays. That means y'all will have a test starting probably Wednesday. Okay? So that means 6.1 through 6.5. And today we're doing 6.5. 6.5 is called inequalities. And the inequalities are the opposite of equalities. So far, you've learned out of 6.1 or 6.2. Which one was equations? 6.2, wasn't it? 6.2, you learned how to do equations with how to solve, how to clear fractions, how to distribute. You learned how to solve for a certain variable. That's all you're going to be doing now. You're going to be doing the same thing. The only difference is in 6.5, instead of an equal sign, you're going to have what? You're going to have these guys. Okay? So the only difference between 6.2 and 6.5 is just that sign. So the mechanics are going to be the same. Just come on, that's fine. How was lunch? Was it good? Well, I'm glad. I'm glad you were able to take your time and eat. And, while all of us are starving in here. Okay? So with the equations, you got 2x plus 4 is equal to 8 minus 8 minus 4 minus 4. 2x is equal to 4. X is equal to 2. So what does x is equal to 2? What does that mean? When you get the answer x is equal to 2, what does that mean? Plug it back in and make the equation what? True. All right, is there any other number that can do that? No. 2 is it. Can't use 3, can't use 4, can't use -5, can't use 100, you can't use 1/2, you can't use 1/3, you can't use -2, you can't use any other number. So 2 is the only number that will make this true. And that's why it's called equality. Because it has a what in it? An equal sign. The difference here is these guys are not going to have an equal sign. These guys are going to have an inequality. Do you use the same mechanics? Yes. You do everything the same that I taught you in 6.2. The only difference is you've got to remember that these two guys always have to deal with an open circle or parentheses, and that means they're exclusive. Exclusive means you cannot use the number. You cannot use the actual number. That's why it's called exclusive. That's why you have to use parentheses or open circles. These two guys, what do they have in that's different from, what do they have in them that's different from these? They have a partial equal sign there. See it? And that partial equal sign means that they are inclusive of that number. Really. And they get a not an open circle, but a what? A closed circle, or brackets. And that means that they are inclusive, meaning that you can actually use that number. So it's very important that you write this down, because when I do problems Wednesday, I'm going to do the problem and I'm going to graph it and I'm going to write it in interval notation, and somebody's going to say, well, how'd you know to use a parenthesis there? And I'm just going to keep on going, because I've just told you that you have to know this. All right? Simple as that. So I'm going to mark this in green, because that means that not only is it important, but if you don't learn it, you're not going to be able to go forward. So one of my little pieces of advice to you in this section is go home and make sure you have this to memory. Okay? The second thing we're going to learn in 6.5, that's the first thing, because mechanics you already know how to do. The second thing is, that's the first thing. The second thing is, we're going to write two different notations. There's set builder notation, and then there's interval notation. Okay? Now, it's easier to see these notations after you graph it on a number line. Once you graph it on a number line, you can see it a whole lot better. Set builder notation says that whatever you do is going to draw a set of braces. I have never been able to draw a set of braces. I am close to 50 years old, and I have never been able to draw a set of braces. Some of y'all can draw them so pretty, and I can't draw them. I've tried, I just can't draw them. Some of y'all, if I really take my time, see, I still can't draw them. I have tried to draw these things, and some of y'all draw them so pretty, and they look like they come right out of a typewriter, and I can't draw them. That's the one thing in math that I've always sucked at, and that's braces. I can't stand it. Anyway, and you put braces and you put X such that, and then you put your answer right there. That is set builder notation. Okay? So draw your set of braces. There's braces, there's parentheses, braces, and brackets. I can draw brackets and parentheses just fine. But I've never been able to draw those. Every once in a while, I'll throw out a good one, but I just suck at it. Just can't draw them. So now you see one thing that I really suck at life. I suck at drawing what? Drawing braces. That's decent for me. It's like a Tweety bird. Let's suck at that. So anyway, braces. I'm glad I can make a couple of people react to something in here. This is going to be called the class. This is the, let's see, what I say, tit on the bull. This is tits on the bull class. This is y'all. You ever seen Patrick Starfish? I'm not saying y'all are dumb as Patrick Starfish. He just has that look on his face, the orb of confusion. Interval notation, you're going to read from left to right. You're going to read the number line left to right, and then you're going to put it in that. It's either going to be brackets, blank, comma, blank, brackets, or it's going to be parentheses, blank, comma, blank. And it's just going to be parentheses, comma, bracket. It can be a mixture of any of those. But you're going to put where it starts and where it ends. Which one do you think is best used or most used? Well, most teachers use interval notation because it's simple. You read the number line from left to right, and whatever you read from left to right, that's what you put. Now, some of this is not making any sense to you, and it won't make any sense to you until we do an example. Okay? So we're going to do an example now, but you got to remember these two notations, and you got to remember what goes on with the parentheses and braces. You got to have those two things in your brain. So, in 6.2, you did this. 2 times x minus 3 is equal to 4. Okay? And you did that in 6.2 and everything was happy. Here, in 6.5, you're going to have 2 times x minus 3 less than or equal to 4. Now, I want you to do both of those. But on this one, over here, I want you to graph the answer on the number line. Graph the solution set on the number line. Okay? Do that right quick. So, this problem, you do it over here, you do it going back in. 2x minus 6 is equal to 4. 2x is equal to 10. X is equal to what? 5. Everybody should have got that, right? Now 5 is the only number that will work with the equality. 5 is the only number that will make this true. But if we go over here and use our same mechanics, 2x minus 6 is less than or equal to 4, plus 6, plus 6. 2x is less than or equal to 10. X is less than or equal to 10. So it's 5. Now, to see this, it might be best to draw a number line because sometimes you have to draw a number line to figure out what the answer is saying. Now, I realize that I have some people in here with no degrees that feel like they don't need a number line. Okay? Let me just put it to you this way. I have several degrees, and I still use a number line. So if I have several degrees and I use a number line, then chances are you probably do too, especially when you're talking about interval notation and set builder notation. But I'm just saying. Okay? So here is 0, here is -5, and here is +5. Now somebody tell me what this says. This says that all my solutions are less than or equal to what? 5. That's what that says. I want you to write that down right here. All of my solutions are less than or equal to 5. So, we take our handy dandy highlighter and we highlight this guy right here. Because that means what? A closed what? So I put a closed circle at 5. If you wanted to put a bracket, you could. Doesn't matter. What numbers are less than 5? Everything to the what? Now somebody tell me from your first and second grade years, which they probably didn't teach you, what is this arrowhead called right here? What is this arrowhead called right here? No, they didn't teach you because it makes too much sense to teach you. This one's called negative infinity. And this one's called what? I tell people that and I say, I have never been taught that all my life. Well, you didn't get your money's worth. Because that is one thing that is so simple for students to see, but they don't teach it because they don't think students can handle it. This one's called negative infinity because it keeps on what? The arrowhead says that it keeps on going. This one is called positive infinity. It means it keeps on going. So, if I wanted to write this in set builder notation is simple because all you do is put your answer in that blank. So I'm going to take my handy dandy. I'm going to write this in set builder notation. All you do is put the brace that you suck at drawing, and you put X such that, and then a blank. And then what goes in that blank? X is less than or equal to what? 5. That's set builder notation for that answer. Interval notation, you just read from left to right. So everybody read that number line left to right. What comes first? That's not rhetorical. I'm asking y'all to interact with me. That means I want y'all to talk. We're going to sit here until y'all answer the questions. Read that number line from left to right. What do you mean read it from left to right? Well, the only part that I have highlighted is the important part, right? So read it. Read the highlight. Okay, you're getting there, but where does it stop? At the arrowhead. What is the arrowhead called? Okay, so let's read it from left to right. Our solution set is from what? Negative infinity to what? To 5. So we write that in interval notation. From negative infinity to what? 5. Now, one thing that you always need to remember, you need to put this with the parentheses on the previous slide where I put parentheses and an open circle. Put a little note. Infinity and positive, negative infinity and positive infinity always gets parentheses. You need to write that down somewhere. Infinity always gets parentheses. Why? Well, just right quick, we'll just settle this right now. I'll give you a $100 bill. I'll give you a $100 bill if you can answer this question. Give me the number that describes infinity. No! You just want that $100 bill. What number describes infinity? I can beat that with 2. What is infinity? What? It doesn't end. So, can you give me the last number of infinity? No. So, can I include the number? Remember, inclusive means that you can use that number. So, with infinity, can I use the number for infinity? Yes or no? No. So, therefore, does it get a bracket or does it get a parenthesis? Is it inclusive or is it exclusive? Inclusive would mean I can give you a number. Exclusive means I can't give you a number. So, what's the answer? Parenthesis or bracket? Parenthesis. Infinity always gets parentheses. It's always exclusive because you don't know the what? You don't know the number. It's like finding the last digit of pi. Nobody can predict the last digit of pi. And if you want to get, I think the furthest somebody has calculated it without a computer or a calculator by hand is, I think, the 25th digit. Okay? But there's no pattern. So if I wanted to write this, the interval notation, the negative infinity will get a what? A parenthesis. Can I touch 5? Yes or no? Is 5 inclusive? Yes, it is. Why? What does that sign down there mean? It's equal to. What does this mean? Remember what I told you? This guy, it gets a what? It gets a closed circle and a what? Or a what? A bracket. Remember me telling you that? So we can't put a closed circle right here. It'd be like 50. So what am I going to put there? Instead, I can't use closed circles, so what am I going to use? A bracket. And that's your interval notation. So there's 2 or 3 things I'm going to ask you to do in this section 6.5. 1, I'm going to ask you to solve. 2, I'm going to ask you to graph it. And 3, I'm going to ask you to write it the set builder notation and interval notation. All right, let's do nerd. Two times x plus 4 minus 6 is greater than 14. All right, do that one. I want you to do it. I want you to graph it on a number line, and I want you to write it in set builder notation and interval notation. 2x plus 4 greater than 14 plus 6, 2x plus 8 minus 8 minus 8, 2x is greater than 12, x is greater than 6. So we draw a number line. Okay, this says all my numbers that work in this equation are above what? 6. So I put a open circle there. Put an open circle there. Take my handy dandy highlighter. And what numbers are greater than 6? Everything to the what? So, set builder notation is pretty simple. Braces, x such that, and then what your answer is. The answer is x is greater than 6. Interval notation. Somebody read this for me, from left to right. That's not rhetorical, I'm asking y'all to interact with. 6 to what? 6 to what? Positive infinity. What always goes on infinity? And what goes on to this 6? Open circle, look back at your notes. What does open circle go with? Parentheses. I'm going to take my handy dandy green pencil. I think it's green. Yep. And I'm going to put open circle right here for y'all. And that open circle tells you that right there is a parenthesis. Okay. All right, let's try one more. Negative 2x plus 7 is equal to 4. Sorry. Okay. I'm not wasting anymore, so I guess I must have did something. Less than or equal to 4 times x minus 2 plus 6. All right, do that one. Okay, remember your smallest bucket. Negative 2x plus 7 less than or equal to 4x minus 8 plus 6. Negative 2x plus 7 less than or equal to 4x. You owe $8, you have 6. What's the outcome? You still owe 2. Now, where's the smallest bucket? Which one's smaller? Negative 2x. I'm going to bring it across the river. And that becomes 7 less than or equal to 4x plus 2x is what? 6x minus 2. Bring the 2 across the river. It becomes 9. Nine 6 comes down to what? 3/2. Somebody check my mind. Now, why did I keep the variable positive? Because if you don't keep the variable positive, you've got to remember 2 more rules. You got to remember to divide through by the negative, and after you remember to divide through by the negative, you've got to remember to flip the what? Flip the inequality. So, you can either remember 1 law, or you can remember 2 laws. Really 3 laws. So which one do you want to do? I personally just want to remember 1. So I keep the variable what? I keep it positive. Now, draw your line. What kind of circle do we put on our number? Closed circle, good. Take our handy dandy highlighter. And what numbers are greater than 3/2? Everything to the what? Everything to the right. So set builder notation is x such that blank, and x is greater than or equal to 3/2. That's set builder notation. And somebody read this from left to right. Three halves, comma, infinity. It's called infinity, people. Don't know. Yeah. Dang old beautiful mind, dang old infinity. What goes on 3/2? Right. And that's how you do the inequalities. Question, gripe, complaint. And that's 3 problems there that should get you ready. And the reason I'm not spending a lot of time on them is because you've done 6.2 or whatever, that's what I said, 6.2. 6.2 I spent a week on, okay? 6.2 is 90% of this. So if you can't do 6.2, you're going to suck at this. And if you haven't done 6.2, there's other questions there we need to address, okay? So if you've pretty much done 6.2 and you made an A on the 6.2 homework, then this is going to be 6.2 with a little bit added on at the end. So there's not a lot of preparation as far as 90% of the problem. You see what I'm saying? 90% of the problem you should already be able to do. And that's down to x is blank 3/2. And that's, you already know how to do that. After x is less than or equal to 3/2, that, and this is the only thing new that's been added to it. Okay? Now, I'm going to go ahead and get the roll. I'm going to cut class early today. No reason. It's just the end of the sections. And that means that Wednesday, I'll go over a test, and I need questions from y'all for Wednesday. I am expecting questions in this section, and I'm expecting questions in the last section we did, which is, what is it, 6.4? So I'm expecting questions from those. So y'all come in Wednesday ready to review, and I'll get the roll, and y'all can skedaddle today.